It's been quite a while since my last AI video, so grab a coffee and get comfortable, because as promised, welcome to my video on the generative image AI model Flux from Black Forest Labs. This video will be catered mostly to AI beginners and people interested in using Flux for anime images and game development. If you want to use Flux for realistic images, you can skip the second half of the video. Unless you like this tech disaster yapping and don't really care what the content is about. In that case, all power to you. Also, keep in mind that I'm definitely no expert on generative AI, so take everything I say with a grain of salt. Disclaimer: we will exclusively talk about the dev branch of Flux and ignore the Schnell model, which is significantly worse in terms of image quality and usually not what people mean when they talk about the Flux model. As the name implies, the Schnell model was designed for maximum speed at the cost of a ton of quality. There's also the Pro model, but this one is not available for local installs, so we ignore this as well. So let's talk about the hardware requirements first. So, just as a heads up, I've seen people reporting they managed to get it working on only 6 GB of VRAM and 40 plus GB of RAM. But honestly, you will lose a ton of speed and convenience in the process. I think going lower than 8 GB of VRAM is overall not worth it, unless you really want to look at a 15-minute progress bar that completely locks up your machine to the point of making it entirely unusable. Personally, I recommend the RTX 3060, which is a 12 GB video card that you can buy new for around 200 euros now. And I've seen them as low as 150 euros these days. And if you want to buy used, you can probably get some for less than 80. I also use 32 GB of system RAM, which helps a lot in those rare cases in which you value precision so much that you want to use the uncompressed model. The advantage of using a 12 GB video card over 8 or less is that it allows to load the compressed Flux model directly into the VRAM, which significantly boosts the generation speed. And as soon as you offload onto system RAM, or even worse, your SSD, your generation speed will go down significantly. Honestly, with SDXL I never cared about speed, because scraping off a few seconds from a process that takes 9 seconds at the worst didn't really matter. But in this case, we are talking minutes, so... Okay, enough talk, we start by installing the UI. For beginners, I would recommend using Forge UI because it's easy to set up and the interface is well structured and easy to learn. And from what I heard, it's also slightly faster than the alternative. The caveat is that it's a bit less flexible, which is not a problem for newcomers, but if you like tinkering around with the tech, then I recommend using Comfy UI instead. Okay, so I opened up the GitHub page of Forge UI. Link can be found in the description below. And if you don't want to deal with the technicals, just scroll down on this page and download the one-click package installer. It also comes bundled with CUDA and PyTorch, which saves you the hassle of having to deal with manually installing those. So this is as simple as it gets. Keep in mind that you probably want to have Forge on an SSD with enough space to hold multiple large models, so I recommend at least 300 GB of empty disk space. After you are done extracting and installing Forge on your drive, you can run the run.bat file in the main directory at any time to start the UI. You can also run the update.bat file if you want to upgrade your install to the newest release. But keep in mind that updating sometimes breaks things, so don't upgrade immediately when a new update is released and wait for the dust to settle. Or in other words, never patch on patch day. Okay, let's set up Flux. And this is a bit harder to do than regular Stable Diffusion models because Forge does not come with the VAE, clip and text encoder models by default because they are massive in file size. Luckily, all the models we will be using in this tutorial use the same text encoders, so we just need to download them once. And yes, this is a problem because I'm living in the third world country of Germany, in which fast internet connection is not a given. Okay, first step, we need the main model. If you're one of those people with more VRAM than God, then you want to use the uncompressed model for the highest speed and quality possible. which you can find the link in the description. But if you're like me and run a pitiful 12 gigs of VRAM, we will use the compressed model that you can recognize by the gguf file extension. In this case, I use the Q8 model, and yes, I know the file size is above 12 GB, but trust me on that, it works. Also, the link to the compressed models is in the description below. You can try out some others as well, like the Q4 KS model if you feel like it. Honestly, it's a bit of a mystery what is faster in the end. I thought that the Q4 model would be faster because it can load entirely into the graphic card VRAM, while the Q8 doesn't, but in practice the Q8 was literally 2 times faster than the Q4. So I recommend just trying it out and check for yourself what's faster on your setup. Okay, in the next step, we need the VAE model, the clip model, and the text encoder. For the VAE, you get that little ae.savetensors file from the official Flux repository. For the clip file, see the link in the description below and download both the clip model and the T5XXL FP16 file, and I recommend downloading the other as well, so that you can swap between them if you encounter any errors or get slow generation times. And now for the last step, we just need to distribute the files into the correct folders. We drop the main model into webui/model/stable diffusion. We drop the AE file into webui/models/VAE, and we drop the clip and T5XXL models into models/text encoders. And now that we're done with all the tongue twisters, we can start Forge UI and generate our first image. Okay, let's run the run.bat file. When the UI opened up, we go to the text to image tab and select Flux on the top. Then we select the main model file and add the AE file, clip and T5XXL models to the text encoder tab. Diffusion in low bits can be set to automatic, but if you want to use a Flux low rank adaptation model, also called LORA, then you set this to automatic FP16 LORA. If the models don't show up in the dropdown, hit refresh. If they still don't show up, you probably have an outdated version of Forge and need to run the update.bat file. The swap method can be left as it is, and the swap location should be shared. I'm not quite sure what the difference is, but I experienced some errors using the CPU setting. So we're using shared because waiting 3 minutes for an image just to display an error sucks. GPU weight can be set to 10751 for a 12 GB card. If you have more VRAM, I think you can set this higher. The reason we use this specific number is that it leaves 1536 megabytes of video memory for inference matrix computing. And before you ask, no, I don't have any clue what this means because matrix mathematics are for wizards. But it made me sound smart, so yeah, I'll take that. On a more serious note, I heard it's a good ballpark number for the extra computing on the GPU. And here we go. Let's generate an example image just to see if everything works. The sampling method and scheduler type are Euler and simple. And I haven't seen any models yet that recommend other settings, so don't bother with the setting yet. Width and height are different from SDXL because the Flux architecture is different from a diffusion model, so there are no go-to resolutions like with SDXL. But I felt like 1536 by 1024 or the reverse is the resolution that worked best on my tests. Going straight to 1920 by 1080 resolution deteriorated the image quality quite a bit. But on the other hand, going lower than 1536 by 1024 didn't really add to the quality, so this might as well be the most optimal setting. CFG scale at 1 is mostly what you want. But keep in mind that if you want negative prompts, you need to increase the CFG scale. But so far, I always felt like it took away from the image quality, so I left it at 1. And distilled CFG is similar to what the regular CFG is for diffusion models. Increasing it usually improves prompt adherence, but usually at the cost of image quality. But there's also something else going on here, because I've noticed that reducing the distilled CFG leads to more realistic art styles, whereas increasing it leads to more rendered, cartoonish looks. Okay, so let's talk about the prompting style of Flux models. Prompting is quite different from the SDXL anime model style, because it wasn't trained on Dunborough checks, obviously, and the T5 text encoder understands human language a lot better than SDXL. What I found to work best is using the following prompt style. And keep in mind that this is also how the examples on the Black Forest Labs website are prompted. You start with a general description of what you want in normal language, followed by a comma. Then a more in-detail description of the individual elements, followed by another comma, and then a list of prompts for singular details. And we get a result like this. Keep in mind that the generation time on my machine was like 9 seconds per iteration, so at 25 iterations, you can do the maths to find out how long it takes. Keep in mind that there is a diminishing returns on the iteration count. This one was created at twice the iterations, and I don't think the quality is really better than on the first image. It's mostly the composition being different. Just to show you what the different distilled CFG rates do, this is a comparison between distilled CFG2 and CFG6 on the same prompt and seed. As I said before, a higher distilled CFG mostly results in a more stylized, cartoonish image at the cost of prompt adherence. And this is a perfect example of this effect. Poor Wolf got the Show Tucker Full Metal Alchemist treatment with a deer. So, we're at the part now in which I will share my personal opinion on the Flux model and what I'm planning to do with it going forward. And if you're here just for the tutorial part, you can stop watching now. But if you like listening to my ramblings, then by all means help me out with my viewer retention and continue watching. Okay, we'll start by taking a look at this image. The result doesn't look too impressive at first glance. The anime style is very flat and boring, especially when we compare it with the super expressive and detailed outputs that we know from the Pony derivative models. But let me tell you why this is impressive regardless. First off, let's analyze the prompt adherence. Every single bit I prompted is in the image. I prompted the headphones, clothing, the ribbon, the movie posters, the computer, the pose hugging the knees, the coffee mug at the table, etc. What I think is even more impressive is that there are literally 0 AI artifacts here. Okay, the mouse shows in the wrong direction, granted, but it's a legit computer mouse. The keyboard has an unusual amount of key rows, but it looks pretty damn good regardless. The coffee mug is clean and correct, the screen is correct. Heck, even the OS kinda makes sense and legit looks like Windows. There's even a small Chrome icon. The movie posters are flawed in terms of text, but at least, at first glance, they look like legit movie posters. The line consistency of the table follows the outline of the table until the end. And we haven't even touched in painting yet, so this is the raw output. Assuming I would want to use this image, I would now just load up my favorite SDXL anime model and in-paint the character at a relatively low denoise and take advantage of the Flux-made composition and coloring. And I'm not bullshitting you here, because this is not what I do on this channel. And instead, I'm just going to show you the result of me doing exactly that. I needed a thumbnail anyway, so it was worth the 15 minutes of in-painting, of which 10 were the hands, not gonna lie. I think it's safe to say that Flux is also amazing at backgrounds. I mean, take a look at this, for example. This is the raw output. There are no artifacts or line inconsistencies here. Even the reflection on the water is almost correct. And if we consider the amazing prompt adherence, creating background images or wallpapers with Flux is really a lot of fun. What also amazes me is how well Flux does in replicating nighttime scenery in general. Most anime models in STXL really struggled with night scenery, but look at this bedroom, even the shadows are correct. You can see a half shadow coming from the window here, and then the shadows on the canvases and the decoration, etc. Okay, let's talk a bit about the community contributions so far, because Finetunes and LORAs have always been essential in generative image AI. So I've tinkered around with some LORAs on Civet Eye. Honestly, most of them weren't that impressive. I felt like they took away from the image quality quite a bit, especially when it comes to backgrounds. But I had much better results with the 2 available anime Finetunes so far. One of them is called Flux and the other is called LYH Anime. Apparently, both are still experimental and have a low amount of training data, but I am positive that we will eventually get good Finetunes. For now, even those 2 yield pretty acceptable results. Let's check out the LYH Anime first. This model aims to emulate the Niji Journey anime style, and I think it does pretty well in that regard. The colors are nice and vibrant, and the line consistency is still surprisingly good considering the insane amount of clutter this model generates. Here's another picture using this model on the hot spring scenery from before. And what you can see is that this model definitely sacrifices some clarity for clutter. Which, don't get me wrong, would be cool for illustrations and wallpapers, but it's just not the style I like. But still impressive. Okay, this one is from the Reimu model, and you can immediately see the improvements in terms of clarity and detail of the anime character. While the background quality is comparable to the regular Flux. So I think this will be my new go-to for creating anime art for now. Something that is very interesting for me is how well Flux generates pseudo game screenshots. I tinkered around a bit with the prompting and made it generate a variety of game screenshots. Now obviously none of them make any sense on closer inspection, but what I think is very cool is that it allows to quickly prototype 2D art assets and placeholders for indie developers. I mean, I can just generate a few screenshots of various UI elements as inspiration and then redraw them and fix them to serve as the basis for my own UI. Take a look at this, for example. It's a clean, minimalistic UI that would look great with some neat animations and some added transparency. Also, those pseudo screenshots of games are always a goldmine of comedy, just from the weird word creations alone. Oh Nork, you're never beating the Yuri allegations with Flavind. This grill gab knildet. Dr. Fannisart is very good at playing nerfers. We gotta max out that Dean bar, because Deutsche Wertarbeit muss genormt sein. And can I vote for replacing all rest buttons in RPGs with a lab button featuring an anime girl? Ah well, that's the end of my video today. I hope you enjoyed it and found some information helpful. I did my best to compress my commentary and the tutorial bits as far as possible. My plans going forward are definitely to take advantage of Flux in terms of backgrounds and UI. Not so much for anime character art though. I think I will stick to my trusty confetti mix for now. Not necessarily because of the quality, but because when editing characters, speed is everything and waiting 3 minutes per image is just too much. But things might change in the future when the quality of anime Finetunes gets better, especially when we get a proper cultured model trained on Flux. I mean, the prompt adherence alone would allow for so much more intense, degenerate stuff than even Pony V6. So the future is bright. But anyways, that's it. And if you found this channel from this video, then definitely check out my devlogs for more cringe commentary or my Discord. Okay, video out. Bye!